Hello everyone, coming to the next continuation part of the yesterday's talk. So here is the screw jack that we are using, and this is the body part, and this is the screw that we are using to lift the part. This is the collar. Okay, so this collar, up to now we have designed the torque that is used to lift the load, that is we have designed the torque that is required to overcome the friction between the screw and nut. Okay, you you all know, while you are keeping a screw jack under a car and you are rotating, and the screw jack is rotating to lift the load, but the car is not rotating. Okay, so whenever the axle load is taken up by the collar, uh, whatever the load that does not rotate with the screw, then the torque required for the torque required to overcome the friction at the collar is given by another formula, that is T2 is equal to mu into W into R. Okay, so let us see. So this is the collar. Okay, so we'll be taking the mean radius. Okay, so in order to overcome, so if you place a load upon this and we will be rotating this handle. Okay, so while you are rotating this handle, the load that is placed on this collar, that doesn't rotates with this collar. Okay, so whatever the friction to overcome whatever the torque that is required to overcome this friction between the collar and the load is nothing but the torque T2. Okay, so that is going to see now. Oh, that we are going to see now. So see here. So torque required to overcome the friction between screw and nut is equal to T1, that is W tan alpha plus phi d by 2. So this is the thing that we are having. Okay, that is nothing but P into d by 2. Okay, so this is the thing that we are having, that is torque required to overcome the friction between screw and nut. Okay, so other thing that we are having is we have to overcome the friction between the collar and the load. So the torque required to overcome the friction at the collar is nothing but T2 is equal to torque required to overcome the friction at the collar. T2 is equal to mu into W into R. So here R is nothing but your mean radius. So mean radius is equal to R1 plus R2 by 2. What is the R1 and R2 here? So the R1 is nothing but the distance between the from here to here, the R1 distance, and R2 is nothing but the distance from here to here. Okay, so the load and coefficient of friction. Okay, so we have to while you are doing the problem, while you are doing the problems, in the question, if he has asked us to find out the total torque, means we have to take like this: total torque T is equal to T1 plus T2. Okay, so you have to remove the torque that is required, the torque required to overcome the friction between the screw and nut, as well as the torque required to overcome the friction at the collar also. Okay, overall the torque required to overcome the friction, that is to rotate the screw, is T is equal to T1 plus T2. Okay, so this is the thing. Okay, so the next concept is we have to know the efficiency of a screw thread. So the efficiency is equal to the ratio between the ideal effort, that is the effort required to move the load neglecting the friction, to the actual effort, the effort required to move the load taking the friction into account. Okay, so let us see that. So efficiency is equal to ideal effort by actual effort. Ideal effort by actual effort. Okay, so here the efficiency of a square thread may be defined as the ratio between the ideal effort to the actual effect. The ideal effect, ideal effect ante entandi, the effort that is required to move the load neglecting the friction. So we are not considering the friction to actual effect, that is the effort required to move the load. By considering the friction, we are taking all the frictions into the account. Okay, so that means we are having W tan alpha by W tan alpha plus phi. Okay, this is the value that we are having. Okay, so that means we are getting tan alpha by tan alpha plus phi. Okay, so we have taken the efficiency of the screw jack is independent to that of load raised. So here you might be in a thought of why phi is there and why phi is not here. So if you have taken there is no concept of friction, means there won't be a friction between the screw and nut, then the phi will be equal to a 0 1. So that is phi is nothing but the friction angle between screw and nut. We are not considering the friction, it's here, so that's why I didn't take the phi. So phi is equal to 0. Okay, so that's why W tan alpha by W tan phi plus alpha plus phi. Okay, so here in this expression we for efficiency we are considering only the screw friction is considered. However, if you consider the screw friction as well as the collar friction also, so if you take both the screw friction as well as collar friction, the term will be, the expression will be efficiency is equal to T naught by T. Okay, so that is P naught into D by 2 by P into D by 2 plus mu into W into R. Okay, that is here that means the torque required to move the load neglecting the friction, okay, neglecting friction by the total torque required to move the load including the screw and collar friction. Torque including screw and friction. Okay, so this is the value of efficiency. Okay, So let us go to the problem, and we will see how we can apply these formulas in the given questions. Okay. Here I am explaining the concept only. You don't need to remember all the definitions and all. You just try to remember the formulas. The efficiency is nothing but the ideal effort by actual effort. That's it. Okay. So if in the question he has asked us to consider the uh, load that is acting on the screw as well as collar also. Okay. At that point of time we have to take this formula. If we consider only the friction, okay, without considering the friction of screw, without considering the concept of collar, means we can take this formula. If we consider both friction that is related to screw as well as collar, means we have to take this formula. Okay, just try to remember this. So let's look at the question. So here is one of the question I am having. So just have a look at this question. Okay, so here is the question. The cutter of a broaching machine is pulled by a square threaded screw of 55 mm external diameter, that is D0 he has given, and 10 mm pitch. So pitch is 10 mm. The operating nut takes the axial load of 400 newtons, that W is equal to 400 newtons, on a flat surface of 60 mm and 90 mm. So he has given the collar dimensions also. Okay, which is R1 is equal to 45 mm and R2 is equal to 30 mm. So D1 he has given as 90 mm, D2 he has given as 60 mm. So that R1 is nothing but 45 mm and R2 is 60 mm, and the internal and external diameters respectively. If the coefficient of friction is 0.15 for all the contact surfaces on the nut, so he has mentioned as if the coefficient of friction is 0.14 for all the contact surfaces. So he is mentioning coefficient of friction will be same for both collar as well as screw and nut. So tan phi will be equal to 0.15 and as well as mu is equal to 0.15. The both will be equal. So determine the power required to rotate the rotating the operating nut when the cutting speed is 6 meters per minute. Okay, so 6 meters per minute he has given. Also find the efficiency of the screw. So the efficiency can be calculated by the formula ideal effect by actual effect. Okay, so the ideal effect is nothing but T naught by T, that is T naught by total torque. Okay, so total torque can be found out by T1 plus T2. So T1 plus T2, we have to do that. Okay, so remember that. So let us write the given data first. So the given is equal to D naught he has given as 55 mm, P he has given as 10 mm, that is 0.01 meters, and load W is equal to 400 newtons, and the flat surface he has given us D1 is equal to 90 mm, that is equal to R1 is equal to 45 mm. Okay, D2 is equal to 60 mm is equal, R2 is equal to 30 mm. Okay, so tan phi coefficient of friction is equal to mu is equal to 0.15. Okay, so n he has given as speed, not exact n, so he has given as cutting speed. So let me write as cutting speed. Later you won't get confused if I write like n is equal to 6 meters per minute, means you will get confused. Okay, so that's why I am writing cutting speed is equal to 6 meters per minute. Okay, we have to calculate the efficiency. Okay, efficiency as well as he has asked us to determine the power also. Okay, so for calculating the power, that is T into omega. Okay, we already know how to calculate the power. Okay, so just try to that. First I will give you a brief view how to do, and later we will go stepwise. Okay, so first thing, for calculation of power, that is P is equal to capital P is equal to 2 into omega. So you all know how to calculate the omega here, 2 pi n by 60. Okay, so T is nothing but your torque. Okay, so for calculating the torque, T is equal to, that is we have to take here total torque. Okay, T1 plus T2. Okay, so for calculating the T1, we have the formula as P into D by 2. Okay, so the P is can be calculated by W into tan alpha plus phi. Okay, so here we will be taking tan alpha plus phi is equal to tan A plus B formula. Okay, so we will be substituting the value and you can find the P value. After that, plus T2 is nothing but mu into W into R. So R is nothing but your mean radius. Here R1 and R2 are given. Later load mu. Okay, so we can get the T value. Okay, so after you can substitute the 2 pi n by 60. N is nothing but he has given in meter per minute, so we'll be converting into revolutions per minute. That is cutting speed by we'll be having pitch. Okay, pitch, we can get the value in revolutions per minute. Okay, so this is how we can get the value of power. So later we can get the efficiency is equal to T naught by T. So that is total torque, that we can get it from here. So T naught is nothing but P into D by 2. So here T naught is nothing but W tan alpha only. Okay, because we are not considering the friction. Okay, so tan alpha into D by 2. Okay, so we will be taking that. Okay, by total torque. Okay, so after calculating that, we can get the efficiency. Okay, so let us go step by step. So that we can have a clear view of this. Okay, so the first thing we have to do is mean diameter of screw, that is equal to D is equal to D naught minus P by 2. Okay, so in the question he has given the D naught value as 55 minus P value he has given as 10 mm. Okay, 10 by 2. So we will be getting same answer. So 50 around, same as that of almost 50. Okay, so the next we'll be going for calculation of tan alpha. So tan alpha is equal to lead by pi by d. So the lead is nothing but your pitch. Okay, so lead angle is equal to P by pi d. So I think you know how we are taking. This is pi d and this will be the pitch. So tan alpha is equal to, this is the angle alpha, opposite side by adjacent side. Okay, so the pitch value is here 10 by pi into 50. Okay, so we will be getting an answer of I have got an answer of 0.0637. Okay, so later we have to calculate the force that is required at the circumference of this screw. Okay, so that is P is equal to W tan alpha plus phi. Okay, force that is required at the circumference of the screw. So we'll be having W, so tan phi alpha plus phi, so that is W is W into tan alpha plus tan phi by 1 minus tan alpha tan phi, sorry. Okay, so we'll be using tan A plus B. So W in the question he has mentioned as 400 newtons he has mentioned, so don't worry, 400 into tan phi will be, so tan phi we have got 0.0637 in plus tan phi in the question itself he has mentioned as 0.15 by 1 minus 0.0637 into 0.15. Just tell me the answer now. So I have got an answer of 86.4 newtons. Okay, so later we have to go for calculation of total torque. So the total torque is equal to T1 plus T2. So T1 is nothing but your W tan alpha, that is P into D by 2 plus T2 is nothing but mu into W into R. So here R is equal to R1 plus R2 by 2. Okay, so the R1 value is 45 plus 30. 45 plus 30 by 2. I think we have to change the pen. 30. 45 by 2. Okay, Nandi. So we'll be getting an answer of 37.5 mm. Okay, so just substitute the values in the above value so that we can get the answer. T is equal to, so the P value is 86.4 into the D by 2, D value is 50 by 2 plus 0.15 into W value is 400 into R value 37.5. Okay, so just check it whether we have substituted anything wrong. So I have got an answer of 4410 Newton mm. I have got this value, so which will be 4.410 Newton meter. Okay, so just check the values of this and let me know if I did any calculation point of view any mistakes. Okay, so the next thing that we have to do is we have to calculate the power. So power is equal to torque into omega. For calculating angular speed 2 pi n by 60. So the n is equal to cutting speed by pitch. So the cutting speed here is mentioned in the question. So the cutting speed is 6 meters per minute. Okay, so 6 meters by 6 meters per minute, meters in per minute. That's why I am taking the pitch value. The pitch value is given as 10 mm, so I am taking as 0.01. Okay, so I will be getting an answer of 600 rpm. Okay, so just substitute the value in omega. 2 pi into 600 by 60. Okay, so I will be getting as 62.84 radians per second. Okay, so we will be getting an answer like this. Later we have to go for the calculation of power. So power is equal to, so the torque that we have got is 4.410 into 62.84. so just calculate the value of power. Okay, just tell me the answer. Later we have to go for the calculation of efficiency. Efficiency is nothing but T naught by T. So total torque we have already known. The T naught is nothing but W tan alpha into D by 2. Okay, by total torque. Okay, so W that is nothing but 400 into, so tan alpha we have got as 0.0637 into D by 2. So D value we have got is 50 by 2. 50 by 2 by torque value we have got as 4.410. so just calculate the value and tell me the answer in percentage. So we have to take the value as 4 in Newton mm. So only we can, because here everything is in mm, so just take the value as 4.6, okay, 4410, 4410, so that we can get the value correctly in some points which we can convert into percentages. Okay, just try to do that and tell me the answer. That is the end here. Just tell me the two values, what is the power value and what is the efficiency value. Okay.